there are two functions, and one maps x2 to this f is this, and the other maps x2 2 by x. So it follows this and this follows this. First he says show that fx is this. So if we kind of take the LCM, this can be written as uh, x x over x minus 1 into x plus 1, and so I find that this can be made the LCM by multiplying this by this. And what do I get? I take the common denominator, and then I x minus x plus 1, and it cancels away and I get this. So this part is done. Now the point is, he says find the range of this. So the range is on the y-axis. If I multiply this again, this will be 1 by x square minus 1. It's a quadratic. So it's a quadratic. Now I can do this in different ways. So one way is I will do the y. I will supposing I would um I want this to be equated to this. I know x is real, so I multiply this and I get y x square minus y minus 1 is 0. So this is the equation. Now, uh, this b x is real, so that means b square minus 4ac has to be greater than or equal to 0, because he is saying here x is real. The other thing he's saying is that x has to be greater than 1. Okay, so first what is a? It's b0 here, because I can write this as plus 0x plus minus y plus 1. So b is 0 and minus go away. So it's 4 into y plus 1 has to be greater than equal to 0. So this is the condition. Okay. Now supposing if I were to I mean that means y into y plus 1 has to be greater than 0. That means a product of 2 is greater than 0, means that they both are positive or both are negative. So y is greater than 0 and y plus 1 is greater than 0, or y is less than 0 and y plus 1 is less than 0. So y is less than 0 and y is less than minus 1. So if this is 0, this is minus 1. So the range is less than minus 1 in this case. And in this case, it is y is greater than minus 1 and y is greater than 0. So if it's greater than 0, obviously it will be greater than minus 1. So here the answer is y is greater than 0. So anything, so that means my answer is coming. First, I will have to uh, see whether this other condition is not causing a problem. Y is x is greater than 1, so it could be 2, so y has to be positive. Okay, if x is greater than 1, so 2, 3, 4, 5, this will become positive, so I can't go minus 1. So this is it can't be this problem. So y is greater than 0. That's the range. Do you have the answer to this? This is y is equal to x square would be something like this, na? Y square x square is this, right? X square minus 1 will transform it down. So I just now told you that if you know the graph of fx, if you know y is equal to fx, then you can find the graph of y is equal to 1 by fx. Both of them share the point minus 1 and 1. Y is equal to minus 1 and y is equal to 1. All right. So if this is the curve, if this is the curve and it's going like this, right? They will share this, right? But we have a root here. Okay. There's a root here. So that will become an asymptote. So it will, one is here, minus one is here. So they're going to share it like this. And the root, it will kind of become an asymptote. It will become like this. The other thing is, if this is decreasing, if this is increasing, this is decreasing. If this is here decreasing, then this is increasing. And when this is positive, this is also positive. So then comes a problem. If this is positive, then there's an asymptote here, okay? So the other graph will kind of come here, all right? So that is why in your solution, you're having this. And because if these were rules, no? The rules were that fx is increasing, this is decreasing, fx is increasing, f dash x is 0 is the same, so that I have done. Then the other rules were that uh, as you x will tend as x tends to here there's no vertical asymptote of fx. So if there is a root has a discontinue at that point, okay, it's a root at the root, and if this they meet at minus 1, they have the same sign. So 1 by fx and fx have the same sign. So here, if the curve was going like the other curve was, if I is this, right? So this was it is so they if this is going like this, right? So this is positive here. So this has to be positive. The problem is there's an asymptote. So it becomes like this. So I'm talking of this curve. Okay, this is the go like this. Now, why does it go like this? You see here, if I'm increasing x, so y is increasing, but if here I'm increasing x because 1 by fx, if this is increasing, this must decrease. Once I know all this, I know the curve. Then the question starts, where is what's the range? Obviously, the range is, this is not included, 0 is not coming, and it's approaching 0 because 1 by, as you increase x and y goes on increasing, this approaches 0. So the other thing is minus, x can't be minus. So that means this part is not there. So actually only this has to be drawn, okay? So y, the curve of this is telling me y is greater than 0. It's not, okay? So that's the solution. The range is greater than 0. It's not equal to 0. Okay, it's not equal to 0. Now, this is where my cross-checking helped because I was, it won't appear when I was calculating there, na? I had by mistake written x is equal to, greater than and equal to. Okay, it can't be equal to 0 because if x is not is greater than 1, so it has to be greater than, okay, it can't be So, because this y will never come out to be 0. And you keep on increasing it. So you can see from this graph also it's not coming. All right.